How y'all doing? Today we are going to be doing some statistics again, week 3. This is not a normal lecture though, just because I'm on drugs. But, I will teach you some things, so you got nothing to worry about. Okay, we're locked in. So we're going to do binomial distributions. Binomial, in other words, are just discrete functions. Okay? So whenever you think of binomial, it is discrete functions. Now, what is a binomial experiment? It's basically things that have chances, like flipping a coin. You have a 50-50% chance. Now, the hard part about the binomial experiments is that you have to figure out whether it's a binomial or not. How do you do that? You do have a couple rules. So there must be a fixed number n of trials. So that means, let's say you flip a coin a certain amount of n's. And you don't change that. It's like if you say, again, I flip it 10 times, you flip it 10 times. Trials must be independent. So if I flip the first coin and I flip a second coin, whatever I get on the first coin does not affect what I get on the second coin. So it doesn't matter. That's basically what you're trying to determine. Does me doing it once affect the second time I do it? Do they relate? All outcomes of trials must be one of two categories. Is basically success or fail, true or false, yes or no. When you flip a coin, it's heads or tails. You have only two options. Probabilities must remain constant for each trial. Is basically when I do experiment 1 and experiment 2, the probability of success, true or false, yes or no, heads or tails, is the same every time I do the experiment. So if I flip a coin the first time or second time, my probability of getting heads or tails is always 50. So you just gotta know these rules for binomial. How do you get your binomial probability? Let's say I tell you, well, what's the probability that I throw a coin 10 times, and then out of those 10 times, 2 times I get tails, or 2 times I get success. And so in the question, it will give you some success rate, blah, blah, blah. But this is the fancy equation. Now, this big ass equation, this part, you can get in your calculator. You just have to figure that out depending on your calculator. This part replaces this whole thing. Okay. So once you do that part and you get that, all there's left is pi. Well, what is pi? Well, it's also pi to the x. This equation is given, and this is n minus x. Your n is obviously, like we said, the number of trials you do it. Your x is what you're trying to get. Like if you throw it 2 times out of 10, your x would be 2. So that's that. Your pi is your probability. So the probability of getting heads or tails is 50%. So your pi would be 0.5. And that's about it. So since it's a discrete, remember from our last lectures, when you want to check the probability of discrete, you do p at 0 plus p at 1. So it's the same exact thing for this one. You do p at 0 plus p at 1, blah, blah, blah. So let's say we're doing coins out of 10. You'll add p at 0, p at 1, and p at 2. Assuming this is inclusive. This doesn't matter whether it's inclusive or not. So just make sure that you know whether it's inclusive or not. Now, so that's this is lecture 5, I believe. Yeah, that's lecture 5. I think this is also lecture 5, which is a sample mean. So there's two things. You have a median. I can't fucking write. Median. And you have a mean. Now your median tells you basically the midpoint. So if I have 1, 2, 3, 4, 5, my median would be 3. If this was odd, assuming the 3 wasn't there, the median would be 2 and 3 combined, and then you divide it by 2. So that would be 5 over 2. Your mean is you add everything up and divide it by the number. So you'll do 1 plus 2 plus 3 plus 4 plus 5, and you do it by how many there is, which is 5. Okay, so these are the two things that you need to know. So this is the sample mean. It's basically so you'll probably think, well, we know before in past lectures, we said mu is our mean. So what's the difference between our mu and our x bar. The only difference is your mu will take, so let's say our set of data, okay? Let's say this is our set of data. Your mu represents the mean of the whole thing. So you'll take the whole thing, you'll add it up, and then you divide it by 7, which is the number of things. However, your x bar is a sample mean, which is technically the same thing. However, your mu for that data will always stay the same. However, your sample mean will differentiate depending on the sample you take. So let's say I take this as a sample. The sample mean of this is going to be different than the sample mean of this. However, the way you calculate it is the same. It's a mean. So you add everything up and you divide it by the number. That's basically what this says, is the sum of all x's, which is, 1, 2, 3, 4, whatever your sample is, and you divide by the number of x's you added up. So that's your sample mean. Now we're going to go into a little bit more mean things. Discrete variables, so for different functions. Because remember, if your data for this was 2, 3, 4, 5, like given like this, and you just add them up divided by n, but what if it's a function? So you can't really just, what are you going to do? Fucking add all the x values on this? Like, it doesn't make sense, you know what I mean? So for discrete variables, this is the way you would do it, which is you will take your x, you will times it by the probability, and then you will add them up. So whatever your discrete variables, I do have 2 examples I'll go through right now. For binomial, which is another type of discrete, in the lecture she showed how you can remember your p of x is this one. So what if it's a binomial? So in the lecture she subbed that into p of x, that big ass ugly looking thing, and then she did some fancy things, which I would say you should know how to do, because she did say she might test us on it, on how you can get from there to just n times pi, aka pi is your probability. So that would also be your mu of x. This, however, is only for binomial. And how do you know it's a binomial? This is how you do. So keep that in mind. For just a discrete variable x, you would use this function, this sum, which is x times the probability plus x times the probability plus x, blah, blah, blah. But for a binomial, you just do n times pi. And that's about it for this part. Here, we'll go on the side here, which we do have a little example. On his way to work, some idiot passes through 10 traffics. So this is 10, remember, n equals the number of trials you do. And then it says, suppose that in the long run, she, the idiot, encounters a red light 40% of the time. So remember, your pi is your probability, 40%, but obviously you don't put it as 40%, you put it as 0.40. And of these signals, and that whether any particular signal is red is independent of whether any other one is red. So if you see right here, what are our rules? Is that a fixed number of trials, which we have, it's 10, it's fixed. Trials must be independent, which means if she gets a green light on one and she gets a red light on the other, the first green light doesn't affect the red light. So this is check, that is check. All outcomes of trials must be one of 2 categories, success or fail, aka green or red. Now you can think about yellow, but you'd be an idiot because that option doesn't really stay, nor are we accounting for it. So it's only green or red. Probabilities must remain constant for each trial. So like we see in the question, okay, I need to fucking use this. Well, I caught it. Okay, our chances is 40%, it's fixed, it doesn't change. Therefore, this is a binomial. So find the mean. How do we find the mean of this bitch? Remember, we said here, after you take this little ugly thing and you simplify it, it's just n times pi. So what do we have? We have, our mu equals n times pi, and we know our n is 10, and our pi is 0.4, which equals 4. Now you think, oh, how do you get 4? Okay, come on, bro. Actually, you probably not think that, but anyways. So next question. A low bar has 4 slot machines. Let x denote the number of machines in use at a specific time. Suppose that the mass function of x is given by this. Find the mean. Now remember, we said for a discrete variable, not binomial, remember, this one doesn't have any chances. Well, the chances are not fixed. That's the first thing. See, your chances for this probability is 20%, 15%, 20%, 25%. It changes. So it's not fixed. And the chances you get one and not the other also changes, because obviously you can see the probability changes. There's no true or false. So this is clearly not binomial. This is a discrete. And so you'll use this function, which is the sum of x times the probability. You have your x, you have your probability. So 0 times your probability, 0.20, which is just 0, so this goes out. 1 times 0.15, which is just 0.15, plus, so this is also supposed to be a plus, but this goes to 0. 2 times 0.20, which I don't even know what that is. And then plus 3 times 0.25, and then plus 4 times 0.20. And that would be our mean for a discrete. So remember, the only things you gotta worry about is, well, is it a discrete? Is it a binomial? If it's a binomial, use this. If it's a discrete, use this. Now we're doing continuous, which is not discrete. Well, no shit, it's called continuous. The mean value of a continuous with density function f is this one. So they'll give you basically some function and tell you it's a continuous. I believe here there's one thing I wanted to point out. Yes. How do you know this is a discrete? Right? Because here you can't really just assume this is a discrete function. Now you have probability, which you can have with a continuous. You have your x values, but how do you know this is discrete? Remember from lecture week 1, I think, or week 2, mass functions are discrete functions. So if it says mass function, that's how you know this is a discrete. And then once you know it's a discrete, you know which formula to use. These are given. Even this one is given. So you don't need to memorize it. You just gotta know how to use it. The mean value, and you should practice so you know how to use them. The mean value of a continuous variable x with density blah blah blah. You basically want to take this. They'll give you some function, and you'll know it's a continuous, and you'll integrate. So you do want to know your basic integration. Okay. Now, will you be integrating from negative infinity to positive infinity? No, because your probability is always between 0 and 1. You can have negative probability, you can have probability more than 1. So this will actually get replaced eventually by 0 and 1. And then you'll integrate, and then you'll get your mu. Okay, so the sample median, remember, so far we've been doing the mean, which is you add everything up, you divide it by the number of n's, and you get your mean. And that's why we integrate, and also that is why we sum up. Now we're doing median. Remember, median is you take the midpoint, and that's about it, really. So if I have a like 2, 10, 22, 35, what is my median here? Remember, you take these two, you add them up, and you divide them by 2. So that would be 32 divided by 2, which is, what is it, 16? Right? Yeah, 15 plus 15 is 30, and then you add 1. Okay, so that's how you get your median for just a normal sample like this. If your sample, however, let's do the same one. Let's add 11 in here. If your sample was odd, then your median is right there, which is just 11. Okay, so it's that simple, really, for hard-coded data, which they give you the numbers for. But if they don't give you the numbers for it, if it's a function, and to be specific, it's a continuous function, then remember, from our data, we just want the middle point. So if it's a function, we want the middle point. Now, since we know a function goes something like blah, 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 actually, let's make it more fancy. Let's say it's a bell curved. Okay, I'm actually a little bit drunk, so that's why my lines are not so straight. There you go. So if I want the middle point of the data, and remember, your median is, no, sorry, that's the mean. So the mean, keep that in mind, the mean is the point where your graph will become symmetric, aka if you flip it, it would look the same. That's the mean. The median is just the middle point. We don't care what the middle, like your graph can look something like fucking like this. we don't care how it looks. We just want the middle point. That's the median. So we just want the 50% of it. Well, technically here we'll actually change a little bit. It's not exactly in the middle because there's less data here, more data here. So we're gonna get the middle of, like, all the data. And so anyways, if you set it to 50%, which is 50% of the data, right? This is gonna be 0.5 and this is gonna be 0.5. If you do that, then you can get the middle point, aka the median. And that's what you're solving for. M. So we're going to go from negative infinity, boom, to all the way to m, but this will usually cancel out and it will go to 0. So you'll do from 0 to m. And then you'll take your function, plug it in, integrate. She did say simple integral, like mu, u substitution. So just make sure you're a little bit comfortable with your integration. But when you set it to 0.50, that's when it gives you the midpoint. And that's basically what you're looking for. So basically when you do 0 to m, what we're looking for is from 0 all the way to some point m that is at the 50% mark. Okay? Now we're going to do sample variance. What is a sample variance? Is basically, let's say we have a long ass graph and we have a point. And we want to know how much this point runs away from the mean. Okay? So let's say I have a function again. And it looks something and it looks something like this. Basically, what I want, let's say my mean is here. That's my mu. Let's say I have some point here. And I want to know what's the variance. Like, how much does this, how off is this? That's basically our sample variance. Okay? Now, why is there 2? You're like, what the fuck is this shit? Why is it 2? So, your regular sample variance, this one, or well, this one, the reason we use this one, mathematically, it's easier to use for adding different units. You don't need to know all this bullshit. All you want to know is that we use it because it's mathematically better. However, we use the standard deviation because in the real world is better. So, what do I mean by that? Hold on, vape break. Okay, so what's the difference? Let's say your data is in meters. So when you use this, this will give you meters squared, which is obviously not the same. That's why we square, that's why there's a squared here, right? So that's why we square root it. So then we go back to m, which is our, the data point, like what the data is measured in. Now you're looking at all this math and you're like, how the fuck? I don't want to know this. How do I get, it's not that hard, okay? It's not all that hard. Here, I'll show you how to do it. It's actually so simple. So you can either go the hard way, which you do this, or you go the easy way, which you do this. Now, how do you do? This one probably looks even more complicated than that one, but it's actually very simple. This one simplifies to just xx over n minus 1, n being the number of data you have. So how do you get your sxx? If you go, which I definitely say you learn this because you need to, you can get this one and this one from your calculator. Okay? Now you're gonna be like, well, can you teach me how to do it with our calculator? No. Because if you do this without a calculator in the test, you will definitely 110% run out of time. So definitely go learn how to do it on your calculator. On a sharp, so if you're on a sharp, but not the cheap sharp, the fancy sharp, if you go and you click on mode, then you click number 1, which is stat, which is what I have. That's why I'm teaching you how to use this one. And then there's one called SD. You click 0. You'll see X and FRQ. And then in the X, you'll put all your points. Whatever points you have, you'll put all of them. And then let's say here, let me put 10, 12, 13, 16. Okay, after you do that, you will press change. And then after you press change, press alpha, and then press 8, which should say stat in green. Once you press there, it will show you a couple options. You want statistics val, which is for variable, I think. And then when you press 0, you'll see it'll give you n, which is what you need for this section, which is aka the number of data points. And then if you scroll down a little bit, it will also give you x bar, which is, I believe that's your mean. Oh yeah, that's your sample mean. You don't need it though. I mean, you could say you need it for this right here, but for this part, you don't really need it because all of this is within. And then you scroll down a little bit, you'll see sum of x and sum of x squared. So this part is the sum of x squared, which is the number. So if you're using the same point I called out, you'll get 609. This one, however, this one is the sum of x, which is in my case 49. And then you take 49 and you square it. So make sure you know the difference. This is different from this. This is the sum of x squared. This is the, I'm not even sure what you call it. I guess it's the sum of x squared, like the way you word it, but it's two different things. So this one you'll get from your calculator as 609. This one you'll get from your calculator as e to the x, and then you square that number. Then obviously you minus and divide by n. Okay, so that's your sample variance. It just basically tell you how the points divert from the mean. Okay, just make sure you also know the difference between standard and the sample variance. The difference is basically one is square rooted and one is not. Okay, the definition. The variance of a discrete distribution. So remember, we did the variance of just points. Now we're doing of a discrete distribution, which is, you see, I didn't memorize all this, so thankfully I do have the lecture open right beside me just to do a little recap mid-lecture. Sample, where is it? There it is. Okay, so for variable x specified by mass function, I actually popped it up, but I don't think I'm gonna use it because it doesn't really say much. But basically, this is the same as this. The only difference is the way you calculate it. So this one, you'll do your x. Oops. Remember, discrete is just random ass variables. We'll do an example down here. So you'll have your x. You'll minus it from your mu. And then, well, you square that. You times it by the probability. And then you just keep summing them up. Now you might think it's tedious. Yes, it is. Now your standard deviation is the exact same thing as we said up here, which is you just square root it. Now, however, for this example, how do you really get this part? We're going to go over an example here, which makes it a lot easier. So the little bar has a 4-slot machines. Let x denote the number of machines in use at specified time. Suppose the mass function. So you don't really need all this, but obviously we know what we're looking for, which is the standard deviation. Now, in order to get the standard deviation, we need the variance of a discrete distribution, and then we square root that. So let's do that. So we want x. So our first x is 0. Remember, for discrete, anything discrete, you just add them up. That's all there is. It's only when you go for continuous, you do the fancy integration. But for discrete, it's mostly adding up a bunch of shit, just adding them up different ways. So what you'll do is x minus mu. Now you'll think, oh, how do I get mu? So you see, if I scroll up, there my mu of a discrete, there it is. It's x times p of x plus x times p of x plus x times p of x plus, okay, so on. So what we'll do is, first let's find our mu. So if we go mu here, which equals 0 times 0.20, well, this goes out actually, the first one, plus 1 times 0.15 plus 2 times 0.20 plus 3 times 0.25, I can't even go more, plus 4 times 0.20. So whatever you get for your mu, that's basically what you'll use here, and it'll be the same for all of them. So now we go back up here. Your mu is the same. You can just calculate it once, it's the same. So then you'll do x minus your mu squared times your p of x, which is 0.20. So that's your first one. Plus, so on. So you'll do 1 minus your mu squared times the probability for that, which is 0.15. Plus, and so on. So that's basically how you do it for a discrete, the variance of a discrete. And this is formula is given. After you get that, you just want to square root that shit. It will cancel out, and it'll give you your sigma for your standard deviation. Okay, nothing too fancy, just a bunch of additions. So now the variance of a continuous, remember, for discrete, you just add a bunch of shit up. It's the same for the median, it's the same for the mean, it's the same for the binomial. They're all discrete. For a continuous, again, it's fancy shit. For continuous, you usually integrate. So the variance of a continuous distribution specified by the density, blah, 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 is this. So you see it's very similar to this part, except you're multiplying it by the function, and you're not summing them up, you're integrating. So that's all you gotta do. They'll give you basically some function and you'll integrate. Now remember, for probability, you'll never really go from negative infinity to positive infinity because probabilities never go negative and probabilities never go past 1. So this will go from 0 to 1 again. And then you'll have your x minus your mu divided by 2 times your whatever function they give you. And then you'll integrate this. Your mu for continuous, remember if we go up, sample median, we don't need that. The mean for continuous is just x from 0 to 1 times the function you integrate. So once you do this part, you'll get your mu. You'll take your ugly looking mu, you'll sub it in here. Okay. And then for your x, you just leave it as is. And then you will integrate, and then you'll get your answer. And that's about it. So now you'll be thinking, well, why do I leave x as is? Because remember, this is from 0 to 1. After you integrate, you'll be plugging into x from 0 to 1. And that will give you your variance. All right, folks. So now we are going to go to the summary. And we are going to summarize all the fancy things. So to find the mean of raw data, so you see if I go all the way up here, there is my raw data, sample mean. So you just sum x and divide it by n. So that's this part. You sum x and you divide it by n. Now to find the mean of discrete data, remember, it's really simple. Whenever you see discrete, add shit up. So for a discrete, it is the sum of x times, p of x. So let's confirm that. It is right here. Mean value of a discrete variable, x times p of x. To find the mean of a continuous data, remember, whenever it's continuous, it's integration. Whenever it's discrete, it's addition. So this one is the integral from 0 to 1, or you can say from negative infinity to infinity. But then you'll cancel out from negative infinity to 0 because that goes to 0. And then you'll cancel out from 1 to infinity because that also goes to 0. Of x, but same as this, except it's f of x, dx. All right, so let's confirm that. So there it is, x times f of x. Find the variance of raw data. That one I actually don't remember. I'm going to be honest. There it is. So that's for your raw data. Remember, you plug them all in your calculator. You get this one, and don't forget, this one is different from this one. This one is x of I squared. This one is you get it within your calculator. Then, don't forget, this doesn't give you your variance. You gotta plug that bitch in there, and then divide it by n minus 1. And if it's a standard, you gotta do your fancy little thingy right there. All right, folks. So that's for your raw data. And then to find the variance of discrete data, that one was the ugly looking sigma, which is, there it is. Oh no, that's continuous for distribution. There it is. So again, this one, we said how to get mu. We already spoke about it earlier. For discrete, is the sum of x times p of x. This one is the sum of x times p of x. Okay, so that's this part. You get it once. Then that's for your all x, the different x variables. Because remember, down here they give you different x variables. So you take them and you just keep summing them up. That's for your discrete. Remember, discrete is sum, continuous is integration. And then to find the variance of a continuous data, you integrate. What do you integrate? Again, your mu, for this part we just spoke over it, is the integration from 0 to 1 of x of x. Okay, you plug that in there, you keep your x the same, and you now make this from x to 1x. Okay, and then you integrate, and then you'll get that. But don't forget, you're not done. If it says standard, you gotta square root this bitch. Okay, and that is really week 5. So all we learned is how to get the mean of raw, discrete, and continuous, and how to get the variance of raw, discrete, and continuous. One more time, I'm gonna sum them up. Summary: the mean of raw is just the sum of all data divided by n. The mean, remember mean, and then you have the mean of discrete is the sum of x times bx. The mean of continuous is the integral of x times f of x. So it's very similar to discrete. One is addition, one is integral, one is p of x, one is f of x. And then now you have the variance of raw data, which I forgot one more time. But if I concentrate for a little bit, maybe I'll remember. Nope, I didn't remember. There it is. That's the fancy calculator part. Usually when you put it, I mean, all of these are in the formula sheet, so you got nothing to worry about. It's just good to remember how to use them. And that ends today's lecture. That is week number 3. 2 lectures. I would say it's pretty reasonable. The only thing you gotta pay attention to is how to find a binomial. And then once you do find a binomial, which is basically the same as discrete, the only part is to find your p of x is, you don't do this fancy stuff. You just do n times pi, and pi being your chances. And for p of x, for this one, for discrete, is this part you get in the calculator. Okay, just quick sum up, and that's about it. Now I'm gonna go sniff some things. Goodbye.